So you see the question. So let's say that transferring to conversions. Okay, so your Egen equals to conversions. Okay, so if let's say that exposed to radiations, your Egen equals to radiations. Okay, so Egen, so capital E is referring to the whole system. So let's say that you can see that so most of the system is so you have one system. Okay, so let's say you have one motor here. So motor they generate the heat. Okay, so they have the heat. Okay, so they have the Egen, right? So we make assumptions homogeneous Egen, homogeneous temperature distributions. Okay, so assume that the Egen here is for the whole system. So that's why we calculate on the capital E. Okay, so you having the Egen multiplied by the capital volume. So the volume of the system. So meaning that the Egen now already is the whole system, not only a certain part. Okay, so that's why we use capital Egen equals to Q convert. Okay, so volume, alright. So volume, this is the thin plate. So area, cross-sectional area, because the heat transfer is, okay, so because surrounding thermal conditions are the same. Left-hand side, they exposed to, let's say the temperature is 20 degrees Celsius. Okay, right. Left-hand side, right-hand side, they have the same temperature. So meaning that the Egen transferring the heat to left-hand side, transferring to the right-hand side. Okay, so now that they achieve the thermal equilibrium. Left-hand side, right-hand side, they have the same temperature conditions. So they have the same H value. Okay, so they have the same pile. So let's say conversions, then left-hand side, right-hand side, conversions. So if let's say one side is including the radiations, you cannot use this method. Okay, so this method only applicable left-hand side, right-hand side, same conditions. If let's say conversions, then conversions. If let's say radiations, then radiations. Okay, so H value are the same, temperatures, your focus on normally temperature are the same. Okay, so the Egen transferring to the left-hand side, transferring to the right-hand side. So now, previously we studied the heat transfers. Okay, so the heat transfer from one side to another side. So the area here is only as one area. Now the heat Egen is transferring to left-hand side, transferring to right-hand side. So now our surface is left and right. So two areas. Left-hand side, right-hand side. So two areas, two surface area. So volume here is so the area multiplied by the length. This area multiplied by the length. Now I have two areas already. So two area multiplied by this distance, the L value. Okay, so start inside, rearrange the equations. So you see the questions, let's say they want to calculate temperature surface, so then you rearrange. If the question asks you to calculate on the T infinity surrounding temperature, so rearrange. Then you get the equations. Generally will be this one. If let's say they want to calculate on the T infinity, then they should rearrange this one, this one. Okay, so this one is Egen equals to Q convert or radiations. Okay, so they ask another kind of questions. They ask you to calculate on the temperature changes, which is the maximum. Okay, so let's say here, alright. Okay, so initial temperatures here. So the heat here. So initial at the center 100 degrees Celsius. Okay, so then they transfer it to the surrounding. Okay, so let's say the surface here. Okay, so after some components here, so maybe surrounding temperatures, any value. Okay, so if the person asks you to calculate the maximum temperature difference, is actually this temperature difference. Okay, so the temperature difference between the temperature at the center and the surface. Same to here. So I learned here. Okay, so this is Tmax. This is Tmax. Okay, so because the heat transfer from the center to the surrounding. Okay, so we will see that the temperature difference is a huge value. So from the surface to L. So now I change the equations actually to dl. Because I know that is the length. Is length. Okay? So now I rearrange. So left hand side we have L. So in the break, so you get L squared over 2. Okay, so you get L squared over 2, right? K, EJ remaining. Right, so dT is the temperature changes is from the center to the surface. Okay, so I name the center, I label the center T naught. Okay, so T naught minus T surface. Okay, so center, rearrange. So this is our delta Tx. Okay, one side is to the surrounding. Okay, so up to the surrounding. So another one is only at the wall, then wall. Okay, so to the surrounding. So depends on the surrounding, either convections or radiations. If let's say if we need the plate, so this is only conductions. So EJ two conductions. Okay.
This one is only applicable if the outside surrounding is same, left and right. If the left and right
Yes.
is same.
Yes. Left and right, left and right difference. You cannot use this method.
All these cannot.
You cannot. Applicable for the system having the same condition, thermal conditions. Okay, so especially like the constant property, also the density. Okay, so density of the fluid or density of the air. So exposed to less than left hand side air, this one oil cannot. Both must be air with the same density, same Cp value, Cp value same. The value are same. That's why I say constant property. Density, the volume, okay, so Cp value, the mass, all constant. There's some system we have this thing.
Ah, that's right.
Questions?
Video chứ.
Yeah.
Oh.
Okay, so this is the general equation side.